The first case is when there is no solution, the ratio of xy coefficients will be same, but not the constants. Also, we can graph the system of equations in Desmos and see parallel lines. For the lines which are parallel, the slopes would be the same, but y-intercepts would be different. Also, if the graphs don't intersect, that means we don't have a solution. Here is an example that we solved in Desmos. If one equation is 2x plus 3y equals 6 and the other equation is 4x plus 6y equals 7, you see some parallel lines. So this system of equations will not have any solution. You are deep into the SAT math section, and suddenly, if you see two or more equations with multiple variables and need to find their values, you are dealing with a system of equations. In this video, we will analyze system of equations step by step so you can solve them quickly and confidently on the test day. A system of linear equations is two equations in the form a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. Here x and y are our variables and a1, a2 are the coefficients of x, b1, b2 are the coefficients of y, and c1, c2 are the constants. When solving a system of equations in two variables, we might come across three cases. We will analyze those three cases next. Sometimes in SAT, we might get a single equation with only one variable, but the thinking is similar to the system of equations. Suppose if the question asks for one solution, again, the coefficients of x on either side of the equation must be different. And for no solution, the x coefficients must be same, but the constants must be different on either side. And finally, for infinitely many solutions, the coefficients and the constants must be same on either side of the equation. Or to solve these equations like system of equations, you could consider both the LHS and RHS as two separate equations, equating them to y, and again apply the three cases what we discussed earlier. Intersecting lines is one solution, parallel lines is no solution, and coincident lines would give us infinitely many solutions. Now, when SAT surprises you with one linear and one quadratic equation, simply, again, you can put them in Desmos and see at how many points do the graphs intersect. If the graphs won't intersect, there is no solution. And if the graphs intersect at one point, we have one solution. And if the graphs are intersecting at two distinct points, and then we have two solutions. Also, you can solve this question as a single quadratic equation by combining both the equations. You could equate mx plus c to ax squared plus bx plus c. Now we have one single quadratic equation, and you could again go for the roots. Here is an example. So we have two equations. So you don't even have to simplify any of these equations. Straight away, put them in Desmos. And these graphs are intersecting at 2 points. So those two would be the solutions to the given system. And be careful, sometimes the questions ask for the x coordinate of the intersection and sometimes the y coordinate. Please carefully answer. And finally, when two equations are given with some missing constants, but you know the number of solutions, you would apply the three cases. In this example, we are given two equations and the coefficient of y is missing in the first equation. So for infinite solutions, we know all three ratios have to be equal. So we equate the ratios and then solve for the missing constants. That's all about system of equations. Please follow these rules. It will be easy and most of the times you could solve using Desmos. The second case is when the system will have one unique solution. For that, the ratio of x and y coefficients must not be equal. When we graph those system of equations, we see some intersecting lines. So when the lines are intersecting, the slopes will be different. And the point of intersection of the graphs would be the solution to the system. For example, if you have two equations, 2x plus y, 3y equals 6, and 4x plus 2y equals 8. When we graph these equations, we see a common point of intersection, which would satisfy both the equations. If you look at the ratios here, 2 over 4 is not equal to 3 over 2. The last case is for infinite solutions where all three ratios would be equal to each other. When we graph the system of equations, we'll be seeing only one line because the lines would be overlapping or coincident. For coincident lines, the slopes are same and the y-intercepts and also the x-intercepts would be same. Both the equations would be identical. They may have the different constants, but the ratios are going to be the same. For example, if we have 2x plus 3y equal to 6 and 4x plus 6y equal to 12, the ratios of all x and y coefficients and the constants is same. Hence, we see only one line, both the lines are overlapping. Hence, we have infinite points of intersection, hence infinite solutions.